Joey Lee is our next speaker. Joey Lee is with Moovel Labs. Joey is a geographer and technologist interested in computation and collaboration. Sorry. His work is centered around maps and explorations of how technology can change our interactions with spaces and places. Joey draws inspiration from various communities, including computational and speculative design, digital media arts, and open source open science. Joey has a Master of Science from the University of British Columbia and was previously based at UCLA, MIT, and the Mozilla Science Lab. Joey is currently living in Stuttgart, navigating the
complexity.
Complexity. It's in German in here. German's not one of my languages. Complexity of the German language and playing with skateboards, pixels, and code. Thank you.
Thanks, Donna. Hello. Hi, everybody. Thanks for coming. This is my first NACIS, and you all are super friendly, so I'm happy to be here. All right, let's dive right in. I'm about to talk about a project called What the Street, and it's a data viz about OpenStreetMap. So let's do this. I'm Joey, and as Donna said, I'm a geographer at heart and technologist by day. And I work at the moovel Lab, which is a small creative group in Germany. We explore new technologies, questions around mobility. And we're really just like a ragtag team of people, urbanists, designers, researchers looking at what the future of mobility could look like. And a lot of times our projects start with a silly question. For example, do all roads lead to Rome? And they end up in visualizations like this. Or can we 3D print mobility patterns of a city with wax? So we built a 3D wax printer, which kind of does that. But most recently, we asked this question about the arrogance of space. And what we're really interested in is how space is allocated throughout cities. And for example, if you look at the image on the left, you can see how much more space is required to transport people using cars versus bikes versus public transit. And on the right, you can see how that all plays out in the city. So we started looking into the numbers, and it turns out that 95% of the time, cars are parked and unused. And for a city like Berlin, that means 4 central parks worth of cars are sitting at any given time, which is massive. And you might be thinking, whoa, that's a lot of wasted space. And that's exactly how we were feeling about this time last year. So Michael Szell, who's a network scientist, and Stephan Bogner, who's an interaction designer, decided that, hey, let's take this question and see what we can do. And basically, the biggest questions that popped out for us were, can we compare mobility infrastructure of a city using OpenStreetMap? And 2, does the mobility infrastructure actually reflect the modal split? And that kind of led us to create this interactive web map called What the Street. All of the links for this presentation are at bit.ly/WTS/links. There's a bunch of stuff, so don't worry about trying to copy them all down. And I'm just going to run you through this demo of what this project, or what this app actually does. And so you start by selecting a city. And in this case, we look at New York. And you can select like your best guess for how much of that infrastructure is reflected by those different modes of transport. On the left, you have car parking, and on the right, you have streets. And those are all the parking lots and streets of New York City in SVG in the browser at your scrolling fingertips. And that's a gigantic parking lot down in Coney Island, I think. And so you can see, like, at the top, you get sort of a marker for how much area you've scrolled past. And if you click on the street elements, for example, you get then this sort of funny, kind of interesting uncoiling. And you can kind of then see, like, whoa, the infrastructure is kind of interesting there. And we make it really easy then to share these GIFs with your friends online. So you scroll, really giving you like the impression of how much space is there. So like 24.3 Central Park's worth of road area is kind of in New York City, according to OpenStreetMap. And then you do the same for the rail space, and you can see that it's significantly less. And then for bike space, which is just tiny. And so you go then to your results, and we give you kind of some feedback, and you see like how everybody else guessed in New York. We give some kind of unique feedback about like how much space you as a citizen would own of that infrastructure based on the data that we have. Some fun facts like the longest street names, the longest streets. We created this mobility triangle, which shows in 2 data points how much space is allocated for a given type of transportation and how people actually move. So this actually answered kind of the question number 2 that we answered, or question that we asked before. And so we have this kind of unique GIF gallery that you can share, and you can even create your own if you'd like. So it keeps going. You have some abstract wall art you can buy, some funny weird elements on the UI or like on the page. We thought about in the future, if there's autonomous cars, how much space could actually be saved in terms of parking. So we did some rough numbers and calculated that. And we have a little call to action with this nice little cat on the bottom. You can explore all these other cities. And lastly, we kind of provide anybody who's interested with like a press kit and a blog post if they're interested in more details. And big shout out to Stephan and Michael. They're really like the driving force behind this project. So without them, it would not have been possible. So that was a lot of stuff. And for the remainder of the talk, I want to just like highlight some of the major features that I think will help inform your data viz projects, or maybe just your own practice in general. So the first thing that you see is this call to action. It's this kind of guessing, scrolling kind of interface. And what we were really interested in was to check to see how people's perception of the data is relative to the reality. And so you have like visualizations like this with the New York Times, where you can see, you can kind of draw your timeline for what, or kind of the data that you think kind of happened during Obama's presidency. And on the right, in Population I/O, you can basically put in your date of birth, and you get all this feedback about like what's your place in the world, like when you'll live, and maybe when you'll die, and stuff like that. So taking inspiration from that, we wanted to really just gauge how people think of their cities and what that looks like relative to others. And in retrospect, we think it would have been maybe more intuitive to give feedback directly. You make your guess, and then you go through this whole scrolling process, and then you get kind of the results. And in the future, we may have kind of reoriented that. So there's like a lot of work that can be done with calls to action, and I think it's just important to hook your audience and encourage participation if you're doing kind of a communication project. And along with hooking your audience, I think another way to keep your audience engaged is to think about your visualization as sort of an overview, and then allow people to drill into it. And so there's this like famous data viz statement called overview first, details on demand. It's sort of the mantra. And the thing is, for our particular visualization, we have like all these parking spaces, and it's just really hard to compare them. And so we thought, why not just aspatialize the geometries? Sure, there's gaps and stuff, but the cool thing is that you get a nice overview and then all of the details all in one visualization. And we use this tool called SVG Nest, which basically allows you to take a bunch of SVGs and stuff them into another SVG. And this is kind of what that looked like in the end. And it's kind of cool. You have like Berlin looks sort of like that, Tokyo, and New York City and Amsterdam, and so on. And you also get these kind of nice, interesting features when you zoom in. You have sort of a wrench, you have this like guitar headstock, you have like a house, this pi, inverse pi symbol, and this electric plug. And in terms of like engaging your audience, I think it can take many forms, but one thing that we think a lot about is making data tangible, something that people can play with. And the trick is sort of how do you make that possible in the browser? And for us, it was really this like scrolling mechanism. You know, to have all of the streets in your browser at one time scrolling through is kind of a fun and interesting way to feel really the relative differences between these places. And so we thought then, like, how do you translate this experience? And we came up with this concept of like the street sausage or the uncoiling of streets and so on. And it allows us to kind of pack all of that street stuff right into one place in a way that can be replicated across cities. And what that meant is that we had to find a nice way to create a network from the street graph. And OSMNX, which is a tool by Jeff Boeing. I don't know if he's here, but he created this wonderful thing that works really well with Network X, which is kind of a really cool network analysis tool. And basically what happens is that you create a network from these lines, and which is just basically a collection of graphs, nodes and edges. And it allows you then to do stuff like this for like geographically unconnected line features and stuff. But taking that just one step further is that like not only is it interesting to like make data tangible, it's also another thing to make it relatable. And throughout the visualization, we tried really hard to create localization, so like features that people can relate to and apply their own understanding given the place that they're in. And this meant kind of defining spaces or places like throughout these different cities that are sort of landmarks that are big enough to kind of show how big actually the area that is taken up by parking could be sort of then translated, I guess. And if you look at the project as a whole, you may notice that maps are sort of a supporting actor in the app. It's not the main feature, and what that meant is like also sketching out a lot of the different types of interactions of this whole app process. And what that usually means is like sketching, lots of sketches, kind of lo-fi wireframes, and basically kind of saturating the idea space about what types of things we want to draw out with our app. And these sketches then turn into like tons of screens we use the Sketch app since we're all using Mac most of the time, and it's just like tons of these ideas about what it could look like as an interface. And that also means like doing screen flows. So I don't know how many of you do this in your own practice, but it's an extremely helpful way of like going through the process of seeing what happens if you click a button, where does it go, what are the kind of logical things that you might miss if you don't sketch all this stuff out and create different iterations of that process. And I'd like to also just give a shout out to like making click dummies. I think if you're a designer or even a project manager and you want to give a really quick overview of like what you want the app to do, this is kind of a cool way because basically it's just a bunch of images that get some nice fancy transition applied to them, and you don't have, it's just kind of a click dummy prototype. It's not actually like coded in any kind of way. It's just like hotspots which trigger going to different pages and so on. So I think it's just a really useful tool for achieving kind of a way to communicate with your developers and so on. And this was like a 6-month endeavor with like tons of sketches, wireframes, design iterations. And I think the idea that we tend to work on is like create as many proposals as possible and filter out the best things that we like from them. So maybe just to say that design is not kind of a one thing that's like magical, it's kind of a massively long process. And 2017 is the year of GitHub repo images on your slides. These are just like kind of a few development notes from the project. We use Next.js with React to do some really nice things in terms of identifying or kind of fixing bottlenecks within the code. Since it's a web browser, you don't want to just send like whatever a 7,000 pixel size SVG to the browser plus all this JavaScript and all this stuff all at one time. And the cool thing with Next.js is that it splits your code up in a really intelligent way and prefetches sort of the parts of the code that are relevant for that moment in time. And you can now also pre-generate static HTML, so you don't have to always generate kind of, or do the computation for the rendering of the HTML elements. So basically, like when you're seeing this first screen and kind of toggling these drag handlers, the rest of the code is sort of loading in the background in an intelligent way. And you can do that with like Webpack and all this stuff, but Next.js just makes it a bit easier. A next thing is sort of handy routing. All of our, like the URLs kind of end up with something looking something like this. And it's cool for like sharing your project or like going back to where you left off in a project. And so if you look at kind of this URL, it's like all sort of sorted by Next.js, and that's kind of a cool feature for projects like this. This is a really handy one. Sorry, I'm running through everything super quickly, but yeah, you'll find all the links and stuff at that link. And request animation frame. It's like totally awesome. If you're using set interval to like do animations and stuff in the browser, it doesn't always make so much sense. So basically, request animation frame is a function that says, hey browser, if you've got kind of a callback in terms of doing whatever animation that you want to do, give it to me just before the next animation frame is rendered. Because if you do use like a set interval function, it'll just like keep calling the function, and if it returns kind of the animation at the wrong time, then you get these weird glitchy things happening. And so if you want sort of smooth animations that don't just like kill your browser, request animation frame is the thing. We included this GIF generator. Basically, we use like FFmpeg and PhantomJS, which is like a headless browser task, which just allowed us to interface with like Mapbox.js and create these GIFs. And yeah, you can read about it online a bit later. Designing for mobile, about 26% of our traffic was from mobile devices, and all they got was this kind of crummy video. And that, we wish we could have built a kind of a mobile site, but the reality of sending whatever gigantic SVG files to a mobile phone and stuff was just not going to happen. So you can do it in your own projects if you like. But despite not having a mobile site, we got lots of press, and that was really exciting for us because you know, you put all this effort into making something, and it got kind of communicated across the internet. And I think a lot of what we do in terms of like standardizing our practices to create things like press kits, which make it really easy for journalists to talk about your work. Those are like high-res images and low-res images, project description, contact info, and oftentimes things that end up in the press kit are like these key visuals, kind of like the parking visualization, which is something I haven't seen before, or this mobility triangle. And those end up in like tweets and stuff online, and it's just kind of a nice thing to think about when you're building a project, to have these shareables that can make it out there. A blog post is really cool if you want to drill deeper into the details of the project and provide technical notes or just more concept or theory-based things. This is something that we actively do in the lab as well. And so just a bit of synthesis. Ideal project pathways generally look like this. This is kind of the model that we run on. We do like research, we collect data, we try things out, and those ideas often inform sort of prototyping and exploration. Those then turn into low and hi-fi designs, and in the end you have development and outreach. But it never looks like that. It more looks like this. And but this is like what happens when you're kind of in the trying to do stuff in the bleeding edge, so to say. And just a shout out, we've got a new project out called Who Wants to Be a Self-Driving Car? It's a VR experience that is kind of interesting and fun. It's sort of a media art thing. So that is the end of my talk. Thank you.
We do have time for questions.
And know that was a lot, but it, saturate and group and hey.
Hi, thanks for the talk. I was wondering if you use any of your visualizations to reach out to like Uber, Google Maps, so that they can use your stuff to promote self-driving cars.
I don't know of anything so far. I mean, we didn't get into anything in terms of OpenStreetMap data quality. There's a paper on that that's coming out from Michael, who is our physicist and a network scientist. So any of those like details would be found in that paper, and anything like referenceable in terms of like legit stuff would be there. This visualization is kind of the show for that paper, which is supposed to come out soon. So.
Anybody else? Okay, thank you.
Thank you.